Hello, and welcome to Practice Quiz 11.1. I'm just going to work through this practice quiz because some of you were asking for a video key. And I said, all right, sure thing. I'll walk through it. I imagine that you really only need to hear me for number 2 and number 3. You're probably fine with 1, 4, and 5, but I mean, I'll do them all just in case. Okay? All right, let's go ahead and do this. I'll do this in red. Okay. So number 1, a conic section equation is given in general form below. It's right here. And then I want to write this equation in standard form and identify the type of conic section and its orientation. So to do that, I need to complete the square, right? And I need to do that on the x's and I need to do that on the y's. And remember, your leading coefficient being it's ax squared or ay squared, whatever, right? The coefficient in front of the squared term, that needs to be positive 1. If that's not positive 1, completing the square does not work. So I will begin by factoring out negative 4 from negative 4x squared and minus 48x. So if I factor out negative 4, I say negative 4 times x squared plus 12x. You see, because that, of course, is negative 4x squared, and then that distribution is negative 48x. Okay. Plus blank. So something goes in that blank. And then the thing that goes in that blank is what completes the square, but we're going to get to that. Then I go to y, right? I say 9y squared and minus 72y. Well, 9 is not 1, so I need to factor out a 9. I say y squared minus 8y plus blank equals, and then I'm going to move the constant negative 108 on the other side. And then I do need to say plus blank, because if I add two quantities to the left side to keep the equation balanced, I must add those on the right side. Okay, so now complete the square means take b divided by 2 and square it. And when we say b, we're talking about this middle term in your quadratics, right? The funny thing is, we can't really call that b anymore, right? Because it's not. It's because this is ax squared plus by squared plus cx plus dy plus e. So I guess you're doing c over 2 squared and d over 2x squared, but whatever. It's not a whatever, okay? We typically refer that to b, okay, from a standard form quadratic. So anyway, 12 over 2 squared is 36, and negative 8 over 2 squared is 16. Yeah. And so then this is negative 108 plus, now it's not just 36, it's negative 4 times 36. So I need to do negative 4 times 36 here. And then similarly 9 times 16. Okay. And now I can factor. I can say negative 4x plus 6 squared plus 9y minus 4 squared equals, I'm going to do negative 108. I could do this in my head. I don't want to today. I feel lazy. I say 36 times 4 is 144. And isn't that also 9 times 16? Oh, so those cancel. So those cancel, which means this is negative 108. Is that right? 4 times 36 is 144. 9 times 16 is 144. So, yeah, those cancel, and that's negative 108. Okay, no problem. And so I'll now divide by negative 108, like so. And let's see what happens. So what's 108 divided by 4? It's 27. So this will be x plus 6 squared over 27. And notice that that is now positive because I'm doing a double negative. And then this is now actually minus. This is, what's 108 divided by 9? I feel like I should know that. I probably do know that. Oh, it's 12, of course. Y minus 4 squared over 12. and then this equals 1. And that's it. That's the process of completing the square. Okay? Notice you're completing the square on both x and y. Some of you have asked, what do I do when it's just x squared? So like, you know, if I didn't have this 48x and it was just negative 4x squared, what would I add? I wouldn't need to do anything because guess what? Negative 4x squared, if that's alone and there's no other x's, that is a perfect square. There's no work to do. Okay, let's move on to the next one. I'll switch to blue. So let's write the equation of ellipse with a focus at negative 6, negative 5, and co-vertices at negative 23, 3, and 9, 3. So here's the thing about this. You don't have graph paper. You have to abstractly consider this object in space. Yeah? So drawing a picture is going to help a lot, even if it's not 100%, to scale. It doesn't need to be. We're just going to use sort of spatial reasoning to figure what this ellipse looks like. So negative 6 comma negative 5, I'm going to put that, because you see I got a negative 21 here, so it's going to be kind of long, right? So negative 6, negative 5 is going to be in the third quadrant somewhere here. It's not exact. It doesn't have to be. And then negative 23, 3 is going to be in the second quadrant. And by the way, if you don't know your quadrants, it's 1, 2, 3, 4, if you didn't know that, okay? So second quadrant is going to be negative 3, 2. Okay, so it's going to be above somewhere like this. And then the last quadrant, 9, 3. And I do want this to kind of look sort of symmetrical about that, so I'm going to say about right there. Okay, and that's what those points are. This is negative 6, negative 5. This point's 9, comma 3. This point's negative 21, comma 3. Now you got to pay attention to what these points are. The negative 21, comma 3 and 9, comma 3 are co-vertices, right? That means this length, that length, maybe, you know what, I'm going to choose a different color just so you can see here. Yellow, this length is the minor axis. And you know that the length of the minor axis is 2b. So if you look at the distance from negative 21 to 9, right, you can say, well, 2b is from negative 21 to 9, which equals 30. I say, therefore, if 2b equals 30, then b equals 15. So I found the side length b. Have I found the center? Well, no, I haven't yet, but I could, right? Because the center is the midpoint. I'll say the center is midpoint of minor axis. Okay? So it's here, right there. And if you think about, if the distance is, if 2b is 30, then that distance b is 15. So you can either do 9 minus 15, and that will get you negative 6, comma 3. Or you can do negative 21 plus 15 and also get negative 6 on both of those. Or if you really are thinking about this, you already know that the focus is here. So naturally, since those are the co-vertices, then that means the major axis is here. So if the x value is negative 6 on the focus, well, then the x value should be negative 6 on the center, because that's where the major axis is. Okay, so there's multiple ways you can find that negative 6, okay? Next, I'll do red. This length here, that red length is, it's not the major axis, it's just the distance c. Distance c, right? So what is that distance? From 3, right? Or I should say from -5 to 3, right? Because it's from this -5 to this 3. That's a distance of 8. C equals 8. I'm going to say therefore C equals 8. Okay. But now I need to know what A is. And I'm going to say, what is the sequence here? What even is the goal? Well, look, you know you need an ellipse. And what does standard form tell you? It tells you the center, it tells you A, and it tells you B. That is what the equation of the ellipse tells us. So I found B, I found the center, I just need to find A now, and then I'm all good to go. All right. So because it's an ellipse, C squared equals A squared minus B squared. Therefore, A squared equals C squared plus B squared. So this equals C squared is 8, so that is 64 plus 15 is 225. So let's do that. 64 plus 225. This equals 289. Which, is that a perfect square? It is. It's 17. I say therefore A equals 17 because 289 is a perfect square. But I actually didn't even need to know that because I'm going to end up squaring it anyway, right? Now let's take a few notes here. Notice I don't need the vertices, right? Maybe I'll put a little stipulation here in purple. I'm going to say, notice I don't need the vertices to write the equation. So you don't need to find those vertices. You don't need to add that all that junk. This picture is sufficient. Notice, did I even draw an ellipse? No, I didn't draw an ellipse. But if I did, it would probably extend somewhat down here, and then I would have an elliptical shape like this. So if you want to complete the picture so that you really have it, you can, but you don't need to. It's not necessary. So if my equation, right, my final answer is x minus h squared over a squared plus y minus k squared over b squared equals 1. Except, wait, is it this one? We must ask ourselves, well, which way is the major axis? The major axis, you say the major, oh my gosh. Major, oh my Lord, I'm so upset. Major axis is vertical. That means A should go under Y. And this is important. This is very important. So this is A squared, and this is B squared. Okay? And by the way, the center was -6, 3. So now I'll say it's x minus -6, so that's x plus 6 squared over b squared. B was 15, so that's 225, plus y minus k, that's y minus 3 squared over the 17 squared, which is 289, and that equals 1. There it is. That's the equation of the ellipse. Cool. All right, let's move on to the next one. And it's the very similar idea. So it's write an equation. So again, we need the center and we need A and B. So maybe in purple again, just so we can see. We need to find the center, the value of A, and the value of B. Because that's it. That's all you need for the equation, right? Okay. And, of course, well, you need to know its orientation. And I just, I don't know if I don't like my handwriting sometimes. And orientation. I think my fiance's home, and I think she wants to go to Chili's. So I need to hurry this up. So here we go. Let's draw our graph again. So write an equation of hyperbola with foci 6, 4, and negative 14. Okay, so here we go. I draw a line like so. I draw another line like so. 6, 4. Yep, that's her. She's coming in. 6, 4. Let's put that about here. And negative 14, 4. Let's put that about here. Because, I don't know, that's roughly where they might be, right? And those are the foci. So I'll call that F1, and I'll call that F2. So, okay, I'm fine. And there's a vertex at 4, 4. So 4, 4 might be somewhere here. And I'll call that my vertex V. Okay? So question is, how do I find the center, right? Well, from this focus to this focus, right? This red line doesn't really have a name. It's the transverse axis, but extended to the foci, right? This red line is to C. Therefore, and you can call, I should probably label these, I'm sorry. This is 6, 4. This is negative 14, 4. So 2C would be from negative 16, sorry, negative 14 to 6, which is 20. So 2C equals 20 tells us that C equals 10. Okay? Also, the center, right? The center is midpoint on the red line. Because, all of these features, both vertices, both co-vertices, both foci, are all equally away from the center. Or I guess each pair, right? Or whatever, okay? Focus 1 is the same distance as focus 2 from the center. Okay. So the center is the midpoint on this line. So what's the midpoint between negative? Well, it's going to be 10, so 6 minus 10 is negative 4. So the center is going to be negative 4, comma 4. And again, you can get that by doing 6 minus 10, since C is 10, or you can get that by doing negative 14 plus 10. Okay? Either one of those is going to get you that x-coordinate of negative 4. Okay. And so you've got the center. You've got C. You also have A, right? Because A is this distance. That distance is A. So from negative 4 to the vertex 4, 4. Whoa. It's negative 4, 4. Oh my gosh. Too many 4s here. From negative 4, 4 to 4, 4 is A. So A equals 8. Yeah? Okay. So A is 8. And now I just need to find B. I say, since it's a hyperbola, then C squared equals A squared plus B squared. Means to find B squared equals C squared minus A squared. So C squared, that's 100, minus A squared, that's 64, which equals 36. Therefore, b equals 6. Now, question is this hyperbola opening which direction, right? Which direction? Is it up and down, or is it left and right? And how would we know? Well, we're going to know from the foci, right? We say it's this one because the foci look like that, right? Rather than that. Okay? So those are my foci. So your curve might look something like this. Can I get a nice smooth curve? Ooh, wow, look at that. It's nice. It's a nice curve, but it's not a hyperbola. So it's going to look like that, and there's going to be another one kind of like that. And I'm just sketching it, right? I don't care. It doesn't need to be super accurate. So it will be facingly, it'll be horizontal. So x squared is positive, and y squared is negative. So let's put all these pieces together. It's a lot, right? Putting all of this together, it's x minus 8. So you're going to say x minus 8 squared over a squared minus y minus k squared over b squared equals 1. Because x is positive because it's opening horizontally. If it was vertically, you need to put the y squared term first and subtract x squared, okay? Anyway, the center is at negative 4, 4. So this should be x plus 4 squared minus, this will be my y minus 4 squared. This is going to be set equal to 1. And so what are my denominators? Well, a squared, a was 8, so that's 64. And b was 6, so that was 36. And there you go. That's the equation. Now again, notice these two problems probably took a little bit of time to explain and take some time to think through, and I know that. So that's why I'm not asking this twice. You're going to do one or the other. You're either going to write the equation of an ellipse given some features, or you're going to write the equation of a hyperbola given some features. It's going to be one or the other. Okay? All right. Finally, number 4 and 5. This needs to be quick because I'm going to tell you, the majority of your time is probably going to be spent on this, completing the square and making sure you can write the equations. This graphing needs to be quick. Sorry. But it does. It does. So where's our center? Let's do this in red. Our center is at negative 6, positive 1, because you just look at the x value, flip the sign, look at the y value, flip the sign. So negative 6, 1 is right here. Where are my vertices? Well, it's opening up and down because y squared is positive. So your vertices are going to be a squared equals 4 means a equals 2. So it's going to be 2 up, 2 down. So up 1, 2, down 1, 2. So this is negative 6, 3, and negative 6, negative 1. Then b squared is 25, which tells us b is 5, which means you're going to go left and right 5. Is that, wow, did I? Okay. Okay, it's fine. It's fine. I think I meant the 25 to be under y when I typed this up, but it's fine. It's fine. It's whatever. It'll be negative 11, 1, and negative 1, 1. The only reason I say this is because you can be just a little off right here. So that's negative 1, 1, and then negative. Yeah, there you go. Oof, kind of stretchy looking. All right, and then I'll do my little box. Now I've got this box, I'm going to make an asymptote straight through the corners like so. one. Okay. And I know that it opens vertically. This is going to approach the legs like this. Okay. And then a big dot here. Approach this way. Approach this way. Beautiful. And where are the foci? Well, let's see, right? C squared equals A squared plus B squared, which is 4 plus 25, which equals 29. So C equals square root 29, which means the foci are from negative 6. So it's negative 6, comma, 1 plus root 29. I'll call this F1. And negative 6, 1 minus root 29. Okay, and what is the square root of 29? I don't know. That's why we're going to use a calculator. It's 5.3, roughly, 5.3. So you're going to go about 5.3 up and down. So I'll say up 1, 2, 3, 4, 5. Not 5, Mr. Spake. 5.3, so 2, 3, 4, 5.3, about right here. Down 1, 2, 3, 4, 5, and a little bit. That's good. That's sufficient. Okay. And then what are my asymptotes? Well, you just got to do rise over run. From the center, it looks like up 2 over 5. So up 2 over 5. Slope is up 2 over 5. That means your equation, right, is y minus the center 1 equals the slope 2 over 5, and it's a plus or minus because I have a positive slope and a negative slope, and then it's x minus 5. Or I'm sorry. X plus 6. And there you go. And you can leave this in point slope form. You don't need to put a slope intercept. I don't care. It's fine. And there's your hyperbola. And it needs to be about as quick as I just graphed it there. Okay? Maybe quicker. I don't know. Because, yeah. Okay. And then ellipse. Now this was graph the conic section and give the attributes. Sure. So ellipse is a lot easier. You can clearly see first the center is at 0, 2. So I'll put 0, 2 here. And now a squared is always the bigger one, so a squared is 36. So a is 6. So it's going to go left and right, right? So it's 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5, 6 to the left. Yeah? And those are going to be my vertices. So 6, 2, and negative 6, comma 2. The co-vertices are going to be 20. Ooh, look at that. So b squared is root 20. Or sorry, well, b squared is 20, which means b is root 20, which is roughly, here we go. Did I really mean this to be 20? I guess so. 20 is square root of 20 is 4.47. So I'm going to go, so my co-vertices, because I'm going up, right, is 0, comma, 2 plus root 20, but you should write it as 2 root 5. And you say, wait, how does he do that? I say because it's 4 times 5, so that's root 4 times root 5 equals 2 root 5. So really you should be writing this as 2 plus 2 root 5, simplify that, and 0, comma, 2 minus 2 root 5. Okay? Don't get too hung up on that. So it goes up about 4.5. So 1, 2, 3, oh my gosh, miscounted. 1, 2, 3, 4.5. Down 1, 2, 3, 4.5. Like so. Okay. And then where are the foci? Well, I need to find C. C squared equals A squared minus B squared. So it's 36 minus 20 is 16. So C equals 4. So you're going to go 4 left and right. So it'd be 4, comma 2 and negative 4, comma 2. So 4. Oh, wow, that's really close, huh? Oh, no, it's not that close. That's 4, comma 2 and negative 4, comma 2. And of course, I like to say F1 is this guy, and F2 is this guy. The equation of asymptote is not applicable. And now, on my iPad, I will try to draw, as best I can, an ellipse. Just try to connect this, and it doesn't need to be perfect, but you gotta make it elliptical. Okay, this one kind of looks like a lemon. That's just me. Okay, and there you go, there's your ellipse. Okay, hopefully that helps. I know it's kind of a lot. Yeah, this quiz is going to be a little bit lengthier. You're going to get more time than usual on this. But you got to come prepared. So see you then, and good luck.